Hello, bachcho. Sat Sri Akal and Namaste from my side. How are you all? So guys, this is Indrajit Singh, welcoming you all into the most sensible platform for an aspirants, those who are preparing for JEE NEET kind of examination. I think it's fun, it's cool, it's awesome. So guys, the new chapter is going to begin today. Directly moving forward from the current electricity, we are on to the magnetism, magnetic field, moving charges and magnetism. Magnetism is having like, 4 kind of chapters, right? EMI, the most important one is this moving charges and magnetism. By the way, all are important. The bifurcation lies on the moving charges and magnetism and matter. Apart from this, EMI and alternating current. Today's class will be quite small. Today I'm going to leave you all early, right? Because we are not going to move into that much complex way. Magnetic field appears quite horrible to all of those students. Not I'm saying to the maximum number of the students, but to all of the students. But today we are going to only discuss about, right? Today we are only going to discuss about this stuff, what actual the magnetic field is all about, right? The source of the magnetic field, what kind of a magnetic field we are going to deal into the upcoming 2 chapters, right? What will be the magnetic field, the characteristics of the magnetic field, the source of the magnetic field, right? What kind of magnetic fields? Now students might be in the thought, sir, what kind of magnetic field? It means what? Magnetic field is a symbol only, na? Magnetic field. What kind of magnetic field? It means there is a possibility, there is not a possibility, but I confirmed magnetic field is because of the moving charge. Matter itself shows the magnetism. These are two different things, right? These are 2 different things. So now it's not about like things are gonna get changing rapidly, right? But you have to concentrate. For that reason, see, to penetrate you all into the world of the magnetism, I've kept this lecture small. Today practically we are only going to understand what actual the magnetic field is all about and what are the sources of the magnetic field. If the moving charge is showing the magnetic field, it's okay. If any matter is showing the characteristics of the magnetic field, it's okay. Lots of things are there. Okay. So yeah, the meme about the magnetic field lines, it always go from north to south, right? Either they're forming the closed loop, whether they are forming the closed loops or not, we can see electric field, magnetic field, light, electric field, magnetic field, light, everything, right? So here the thing is that, let's begin. So we are going to move forward to the most important part, moving charges and magnetism. The chapter name is moving charges and magnetism. Among them, the first is magnetic field, right? The first is magnetic field. Now, first of all, what is the reason of magnetic field? If I want to convey a very simple message in front of you all, right? The 12th syllabus is designed like such a way. First of all, we always used to study about the stationary charges, right? In electrostatics, into the capacitance, yes, in some part of the capacitance, we can say the charges are also moving, okay? But in electrostatics, we always used to study about the stationary charges. Second, into the capacitor and current electricity, right? We used to study about the moving charges. Okay, now many students might be saying, sir, moving charges shows the effect of the magnetism, then why haven't moved on to it? Why we didn't move on to it, right? So I must say I have kept this thing. See, whenever the capacitors and current electricities are taught, those magnetic effects are kept aside because it is important for beginners, right? It is important to understand all of those concepts fundamentally, right? You have to grab it up. So as of that reason, okay, we have kept, right, the one who has, this is a traditional syllabus, right? We are not moving on to the updated one. This is a traditional one, and the traditional syllabus states that, right, first we have to understand the moving charges without effect of magnetism, then we are moving forward to moving charges and magnetism, and then we have to move forward how matter shows magnetism, right? And after that, combination of electrostatics and magnetism, we directly move on to the electrodynamics, in which we are having the dual nature. Dual nature is a part of the modern physics, but electromagnetic waves, right, how they are getting produced, how electric field and magnetic field both contribute, okay, in the formation of the the electromagnetic wave. Lots of things are there, the spectrums, blah 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 blah, right? So this is how the syllabus is, and then we suddenly, when we will move on to the electromagnetic wave, then again we are having a doubt whether the light is an electromagnetic wave. Then we will move on to the dual nature, then we will move on to the external part, that is the ray optics, and finally the modern physics. So this is how the entire syllabus is designed. Okay, now in electrostatics we studied about the stationary charges. The stationary charges is having the capability to produce the electric field, right? Stationary charges, right, has the capability to produce the electric field. But what about, right, what about the moving charges? In electrostatics, charges were stationary, so they were only showing the electric field, right? But here the question lies, why, if the moving charges produce a magnetic field, then why we didn't learn into the capacitors and the current electricity? Because if we have dealt about the current, right, if we have dealt with the current, then somewhere the charges are moving, then and then the current is getting constituted, right? Okay, a body constitutes current only when it is having the moving charges. So as I told you all, it is important, being in being at the beginners level, it is important to study the electric effect only. Now in this chapter we are going to move forward for the magnetic field. Now see, magnetic field is all about what, right? First, slowly, okay, the circuit is showing there are some magnetic effects of the current, was first discovered by Ørsted. Okay, the famous experiment that you all are aware of, one circuit was kept, on that magnetic compass was kept, right, and the needle was getting aligned into the direction of the current. This was a very famous experiment, right, conducted by Ørsted. Okay, the very famous experiment conducted by Ørsted. So same thing I want to convey. Magnetic field, electric current shows the magnetic effect, was first discovered by, and here comes, after the experiment of the Ørsted, here comes the concept of the actual magnetic field and its respective field lines. So here I am going to have the very simple classification. Suppose this is the stationary charge, right? This is the stationary charge. It is having the capability, right, okay, to throw out the electrostatic force around it. Okay, so this shows only the electric field, right? But whenever the charge is moving, this is the first point that we want to convey. Okay, the second point is all about the moving charge. For a moving charge, right, for a moving charge, what happens? See, The moving charge is going to show the electric field and magnetic field both. Stationary charge shows the electrostatic effect only. On basis of that, we understood the potential energy, the electrostatic potential, right? Electric field, the forms of electric field, the characteristics of the electric field. On basis of that, we understood Gauss law, right? When the current carrying under the charge conductor if shows, then how the variations of the electric fields are measured. Lots of things we have discussed. Tomorrow we are going to move forward for the Biot-Savart's law and its respective application. Today, simply you have to just at the back seat and you have to understand what only the magnetic field is all about. What actually the magnetic field is all about. You have to just understand the very simple concept. So electric field is all about the stationary charges. Magnetic field, it is all about the moving charges. Moving charges are only having a capability to produce the magnetic field despite of a matter having in magnetism. Charge is moving. See, till now, we have moved on to the concept of the electric field. Now, for the moving charges, we are going to move forward with the magnetic field. Now, lots of things we are having into the mind. How magnetic field is, right? What will be its respective direction? How you are going to identify that? What is the pictorial representation of the magnetic field, right? How you want to classify the magnetic field? Whether the magnetic field depends on the frame or not. Right, lots of questions you might be having into your mind, and it's okay. This all are the myths, right? This all are the questions. You can say whether it is a myth or a question needs to be resolved before moving on to the most important application, that is Biot-Savart's law. It is important to resolve. So how we are going to resolve this stuff? Very simple. First, for a moving charge, see, there is a difference. Okay, if I'm talking about the magnetic field, see, it's a very simple cause I'm going to, a very simple message that I'm going to convey in front of you all. If I'm talking about the magnetic field, so first thing that you all should understand, magnetic field that is produced as because of moving charge, this is different as because of current carrying conductor. This is different. Matter shows magnetism. This is different. Somewhere this both are correlate with respect to each other. In 3 of the cases, we are not having any kind of the classification of the magnetic field, but these are the 3 kind of the sources in which we are going to deal with the magnetic field concept. 3 different ways magnetic field will be introduced in front of you all through 3 different ways. Students always, why they always used to get bored into the magnetism, why they hate it. Okay, why they always get bored into it, why they hate it, the reason behind it, they are not actually able to grab, right, the logic behind it, the source, the representation of the magnetic field, how it is represented into the multiple ways. The entire 2 chapters are based on the 3 simple statements. Magnetic field, as because of the moving charge, it is represented into different way and having the different concepts. Right, magnetic field and its respective application is because of the current carrying conductors, and magnetic field, the matter that shows the magnetism. Entire 3 chapters depends on this, right? Entire 3 chapters. So from now onwards, for the upcoming 2 chapters, right, whenever whatsoever thing you are having into your mind, it's okay, it's not a right, it's good, right? Whatsoever your thing you are going to have into your mind, okay, I want to convey a simple part, right? I want to convey the very simple part that moving charge, current carrying conductor, magnetism, matter shows magnetism, right? So these three are the different. From now onwards, whenever you're going to deal with the magnetic field, this should always be in your mind. You should always get a click about it, right? So now let's move on. How the magnetic field appears for the moving charge and whether they are frame dependent or not. Suppose this is a charge. The charge is moving. For now, it is moving with the constant velocity, right? Okay. How magnetic field are produced around it, right? How magnetic fields are produced around it and what will be its respective direction. Okay. See, suppose, let us take an example. This is a charge. The charge is moving on this specific straight line with the constant velocity. Charge is moving on the specific straight line with the constant velocity, right? This is how magnetic fields are produced around it. Like this way. Suppose charge is moving like this way, then magnetic fields also moves with the respective value of the charge. If the charge is moving like this way, then magnetic field also produces whatever the magnetic field that has been produced also moves with respect to the charge. Okay, I'm going to show, right? Okay. Suppose this is a path on which the charge is moving. Okay, the path on which the charge is moving, right? So it is having, okay, like this way, magnetic field lines are produced. Now suppose at t is equal to 0, this is the position of the charge. Okay, now let us take an example at t is equal to time t1. The position of the charge is somewhat this, right? Okay. Then the magnetic field is produced like this way around it. Right? Yes or no? Okay. Suppose, let us take an example. This was the time when I started analyzing the charge. I am talking about the time t is equal to -5. Right? Charge was at this position. Right? Then how magnetic fields were? Right, magnetic fields were produced into the form of concentric circles. Magnetic field as because of the point charge that is produced as because of the concentric circles, right? Yes or no? Concentric circles. The thing is quite important and you all should know it. Concentric circles, right? So this is how the charge that is able to produce. This, whatever the depiction, this all are the pictorial representation of the magnetic field, right? And that is nothing else but the magnetic field lines, right? This is how the moving charge that produces, like the magnetic field, like this way, right? Now, if I'm talking about right, if you are talking about, right, the magnetism that is showing this is a north pole, this is a south pole, right? That is a matter that is showing the magnetism. Now what kind of the matter that can show the magnetism? Even aluminium, steel, matter, earth itself is a matter that shows the magnetism. Bar magnet is the best example of the depictions of the magnetic fields around it, right? Generally, it is said that magnetic field starts from north poles and evolve at the south pole, right? It starts from north pole and it, right, ends at the, right, south pole, and inside the magnet it moves on from south to north, right? This kind of the depiction of the magnetic field we are having. This kind of the depiction, the magnetic field we are having. Okay, this is as because of the how this is a pictorial representation of the magnetic field lines. The appearance of the magnetic field, the pictorial representation of the magnetic field nearby the bar magnet. Like this way, the entity or a moving charge or a current carrying conductor. Now suppose, let us take an example how the current carrying conductor shows the magnetic field. Okay, so this was all about how the matter shows the magnetism, right? We discussed the three ways. Now first, how moving charge is showing the magnetism, how matter shows the magnetism, how the current carrying conductor shows the magnetism. Okay, there are lots of applications, right? There are lots of application, right, in current carrying conductor that completely depends on the Biot-Savart's law. Okay, it depends on Biot-Savart's law that we are going to do tomorrow. Okay, so the current carrying conductor, let us take an example. This is a conductor that is having the positive charges distributed onto it, and the direction of the current is like this way. Okay, how we are going to identify the directions of the magnetic field? Like this way. Like this way. Okay, this is a direction, right? This is not a direction, this is a pictorial representation, right, of the magnetic field, okay, through the field lines. What will be the direction of the magnetic field, right? How it is identified, everything we are going to discuss, don't get worried. Okay, but the important thing was how the thing that I want to convey, okay, through three different applications we are going to understand, through three different representations, right, we are going to understand the magnetic field. The first one, that is as because of the moving charge, right? The second one as because of the magnet, and the third one, right, as because of the current carrying conductors. Now, what you want to tell about, right, the next question, whether the magnetic field, see, I'm going to convey this message through very simple reason. See, this is a very famous question. Observer is standing on the ground. A very simple question that I'm going to convey. It is having the zero velocity. Charge is kept stationary. Velocity of the charge is also zero. So it means one thing is sure, what stationary charges produces electric field. But my question is, suddenly if, right, suddenly if observer starts moving with the velocity v, right, whether he is going to observe magnetic field or not. This is a very famous question, that electric field and the magnetic fields are frame dependent or not. Right now, let us take an example. It is an inertial frame of reference Fy, as he is not having, he is at that rest. Suppose even he is moving with a constant velocity, right? Okay, or the velocity of the observer is getting accelerated. Okay, it means it will be converted into the non-inertial frame. Okay, now this non-inertial frame, in non-inertial frame of reference, right, observer is a non-inertial frame of reference. Now, whether he is going to see the magnetic field or not, whether he is going to experience the magnetic field or not. Okay, so my question lies, whether the electric fields and magnetic fields, so this is a solution. Electric field and magnetic field are are frame dependent. Electric fields and the magnetic fields are frame dependent, right? They are what? Frame dependent. Generally, I've told you all, the stationary charge always produce electric field. Many students might be having the question in their mind, sir, this charge is stationary. The hell observer is moving or not? We are not interested into it, but you told us that charge is stationary. It means it is only going to produce the electric field. And if it is moving, then it is going to produce the magnetic field, or else if it is a matter, then it shows the magnetism. This is not a current carrying conductor. This is not moving. This is not a matter. This is just a simple charge that is stationary, a point charge that is stationary. How it will show magnetism? So for that reason, I am saying the observer, right, it is into the non-inertial frame. Anyhow, if there is inertial frame, I can't even say inertial frame because it means that velocity is constant. Anyhow, if it appears, whether from the charge point of view, right, from the ground or from a moving observer, from the inertial or the non-inertial frame, from any of the frame, if it feels that charge is moving, magnetic field is produced. From any frame of reference, if it feels charge is moving, right, if it feels charge is moving, it means that a very simple thing that will come up in front, right, there is magnetic field. Okay, there is magnetic field around it. Yes or no? Okay, so this is a very simple concept. Magnetic field, it will again discuss into the electrodynamics. Yes, magnetic field and the electric field both are charge dependent. Okay, both are charge dependent. Now let's move on to the characteristics of the magnetic field and its respective field lines. Generally the field line concept is going to come up into the magnetism and matter. Okay, right now here, sorry, not right now here, but right now only we are going to discuss about what actual the magnetic field is, a respective direction and its source is all about. Because from tomorrow we are going to start with the Biot-Savart's law application, and that would be the most important stuff, right? That would be the most important stuff. So here, magnetic field lines, the characteristics of the magnetic field lines. The characteristics of the magnetic field lines, right? This time I have to take one bar magnet. This is a north pole, this is a south pole, right? And I have to depict the magnetic field around it. Right. So there exists some points, right, about the magnetic field. First, magnetic field lines. First of all, magnetic field lines are the pictorial representation, right? Magnetic field lines are representation of magnetic field area. MF stands for magnetic field, right? The magnetic field lines are the pictorial representation of the magnetic field area. As like electric field lines we were having, right, for the electric field area. Okay. Second, magnetic field lines starts from north, ends at south. Right, it starts from north, right, it ends at south. Okay, it starts from north, it ends at south. Okay, inside the magnet we are having the magnetic field lines from south to north. The same thing we have seen into the electrostatics, right? Positive charge, the direction of the electric field that a positive charge, a single positive charge produces is radially outward, while the direction of the electric field that for about the negative charge, a single point in negative charge, it is radially inward. Similarly here, the north pole is analogous to the positive charge. Why? The magnetic field is getting radially outward. South pole is analogous to the negative charge, right? Okay. Third, inside the magnet, right, it is from south to north. Okay, the tangent drawn at a point on the magnetic field line will show the direction of the magnetic field. There are two ways to understand how the magnetic field direction is defined. Basically three ways. When you are going to deal with the current, the direction of the field is different. When you are going to deal with the matter that is showing the magnetism, the direction is different. Whenever you are dealing with the point charge that shows the magnetism, the direction is different. And in all of those concepts, the single logic is involved, but it is represented into the three ways. If I'm talking about this matter that is showing the magnetism, right, then tangent drawn at any point shows direction of magnetic field, right? Tangent drawn at any point shows the direction of the magnetic field. Two electric field lines never intersect each other, but here same concept lies, right? Two magnetic field lines never intersect. The same logic, right? If they intersect, then at the point of intersection, right, two tangents can be drawn. That is not so possible. It means I'm standing at the same position, I'm having the option of two directions, but at a single point of time I can only move in one, right? Two magnetic field lines never intersect, right? Second, they always forms the closed loops. This is for the matter I am talking about, right? Okay, this is a matter I am talking about. Now what about the magnetic field lines for the moving charge, right? Suppose this is charge that is moving with the constant velocity. The magnetic field lines are produced like this way, depending on the position of the charge, right? Magnetic field lines are produced like this way. Okay, so in this case I want to tell you all how you are going to identify the magnetic field. Okay, how you are going to identify the magnetic field within it. Okay, it is important. See, at any point of the time when any number of the students are getting confused, please don't mind. Okay, you can immediately rewind this lecture. Okay, and you can watch it again. Magnetic field is because of the point charge is in form of concentric circles. It is in form of concentric circles, like this way you can see. Magnetic field varies if we are moving away from the charge. Okay, one thing that has been remaining into the previous part, that here magnetic field intensity is higher when magnetic field lines are closely spaced. Magnetic field lines are largely spaced, magnetic field intensity is less. B varies. See, if we are moving away from the charge, then slowly this concentric circles get disappeared. Slowly these concentric circles get disappeared. It means somewhere if we are moving away from the charge, magnetic field is getting weakened. Somehow magnetic field depends on the distance. Right? Distance with respect to the positive charge you are moving on. Magnetic field varies with respect to the distance, where n can be any value. Right? Magnetic field varies with respect to the distance. So this is all about the point charge. How you are going to identify the directions, right? Direction of magnetic field, it is going to be right hand thumb rule. Basically, if I am talking about, there are lots of ways. We are having the Ampere circuital law also, right? We are having the Fleming's left hand rule also, right? We are having the right hand rule also. But if you are using the right hand rule into the most appropriate manner, I guarantee that nothing is going to touch you all in this respective chapters. Nothing is going to touch you all into this respective chapters, right? So I want to need to search my slider. Yes, here it is. Okay, it has been lost. Okay. So this is about the characteristics of the magnetic field, about the point charge. Characteristics about the magnetic field, right? About a matter that is showing the magnetism. The directions of the magnetic field is defined into the three ways I told you all. One, we are having right hand rule. The most common are two ways, that is Fleming left hand rule. For the direction, for identifying the direction of the magnetic field and the this force, right? It differs. For matter it differs, for a point charge it differs. See, the most important thing about this lecture is all to show you all what magnetic field is all about. Entire thing is on this three. Concepts of moving charges are different. Concept for the current carrying conductor, a bit different as compared to this, and these two are interrelated to each other. The matter shows magnetism, it is a different part. The students always used to get confused, and this is going to be the most confusing part. Matter bhi wahi, charge bhi wahi. Dimag kharab ho gaya boss. Right? Dimag kharab. Yes or no? So I want to convey a very single message. Magnetic field is because of the point charge. See, now I'm going to write down the most important stuff. This will clear out all of your concepts. Moving charge, right? In this, we are going to study magnetic force and its respective application, like Lorentz force and everything. Right? Okay. Biot-Savart's law and its application. Right? For a moving charge, okay, Biot-Savart's law and its application. For a current carrying conductor, we are directly moving forward to the torque. We are going to move forward for the force, the magnetic force. Right? Magnetic force for the current carrying conductor is a different equation. Magnetic force for the moving charge, it is a different equation. Right? We are going to move forward torque. We are going to move forward for the force. Right? Okay. We are going to move forward for the flux. Okay. Matter shows magnetism. We are going to move forward, right, to the earth magnetism. To the magnetism that has been showed by the bar magnet and its respective, right, neutral points. Okay. Ferromagnetic materials, diamagnetic materials, paramagnetic materials, right, magnetic susceptibility. Okay. coercivity, hysteresis, everything comes on, right? This matter show. So these are the different concepts. The force, right? The Lorentz force, the direction of its, the Biot-Savart's law, its respective applications, right? The force as because of the current carrying conductor, right? Force as because of the current carrying conductor of any arbitrary shape and size. Right? Of any arbitrary shape and size. Okay. Force is because of the conductor of any arbitrary shape and size. How magnetic flux changes and produces the EMF that we are going to see into the electromagnetic induction. After this, magnetism. Earth, bar magnet showing magnetic field is respective field lines at neutral points, paro, dia, para, artificial magnetism, magnetic dipole moment we are going to see in both of these cases, right? How the current carrying conductor acts like a dipole, right? How this dipole are used into the magnetism. Okay, so this is a chart and it is going to be the quite important one. Okay, this is a chart and it is going to be the quite important one. Right? So students, it is all about how magnetic field, why it appears quite complex, why magnetic field appears quite complex in front of you all, right? The simple reason behind it is not represented well, it is not classified well. This is an appropriate classification of the concepts of the the concept associated with the magnetic field that we are going to study into the upcoming 2 chapters. I'm moving aside if someone wants to take a screenshot of it, right? On the countdown of 10 seconds. This is the most important classification, guys. And whenever, right, we are going to study all of those concepts into the upcoming chapters, okay, at each and every moment I'm going to convey you all, I am going to remind you all about this presentation slide. Okay, I'm going to remind you all about this presentation slide. So on the countdown of 10 seconds, it's 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So what we studied? We started with electric field, electrostatics, the actual classification, electric field, right, and moving charges, the magnetic field into the 3 different approaches, right, the pictorial representation of the magnetic field and field lines, right, the magnetic field that was just because of the point charge, this was a matter showing magnetism, right, this is a current carrying conductor that shows the magnetism, right, okay, whether the magnetic field and the electric fields are frame dependent or not, right, the characteristics of the magnetic field when magnetism shows the matter shows magnetism, this is for the point charge, right, direction of the magnetic field is different, right, for by the left hand rule, by the right hand rule, lots of things are there. Okay, yes or no, guys? Yes or no? Okay, so this lecture was only to convey the message what the magnetic field is all about, right, and how differently, right, magnetic field we are going to study. Okay, so I think that's enough for today. I think we have to move on. It's time to go, right? So guys, this is Indrajit Singh signing off from the desk. Bye bye. Okay, again I will be waiting for all of your feedbacks beneath the video, right? So guys, it's time to go. Slowly we will move on because the magnetic field is a very complex. If you are going to get stuck into the maze, no one is going to grab you out. Not a single person is going to grab you out, right? So it is good to move with the flow. It is good to move slowly and steadily. Yes, we are going to win the race. So guys, it's time to go. This is Indrajit Singh. Again, we are going to come back tomorrow with the concept of the Lorentz force, not Biot-Savart's law, Lorentz force, and how, right, magnetic field, how charge behaves, right, when they enters the external magnetic field. Okay, so again we are going to come back tomorrow. This is Indrajit Singh Bacha signing off from the desk. Bye bye. Sat Sri Akal and Namaste from my side, Bacha ji. Bye everyone. Stay at home, stay safe, stay healthy amidst this pandemic. Bye, Bacha ji.